Hello again, you sick, twisted weather freaks, and welcome to another fun-filled, action-packed, and intellectually stimulating edition of This Week in Weather. I'm your host and meteorologist, DT, from Weather Risk, your commander of chaos, your captain of confusion, your commander of catastrophe. Let's talk about this week in weather for June 14, 15. Let me apologize first for getting this out close to midnight. There's a lot of information on these slides here. This is taking a long time to put together, but the weather going into the summer season here is incredibly active and very different with a lot of really fascinating things to it. So, again, apologize for getting this out late, but you'll see there's a lot of information. There's a lot of crazy shit going on out there. So, let's see what's going on here. First, we're going to be talking about the arrival of El Nino in force here. We're talking about more omega blocking patterns in the northern hemisphere, which is causing the weather patterns across Europe and North America to do all sorts of crazy stuff. Not allow rain in the Midwest, pushing the rain to the south, making it very cool on the East Coast, causing the ocean water temperatures to explode in the eastern Atlantic Ocean and up towards Europe, causing a drought and a heat wave in Europe developing early. All sorts of problems here with the omega. And then, of course, that is directly connected to the incredibly warm oceans. We'll talk about that. And then there's also a possible East Coast low pressure area, a nor'easter or a coastal low, don't know which yet, June 19th, 20th, and 21. And then early season possible tropical depression, a TD, tropical depression, next 6 or 7 days in the southwest tropical Atlantic. So let's get right to it. Whew, that's just the first slide. Can you believe that? All right, here we go. Here's El Nino, the latest information here as of June 12th. And what's happened, as you can see, obviously now, in case you don't know this, the area with the most critical in determining El Nino or La Nina or neutral conditions is region 3.4. So you have those different regions here. You can see how very, very warm it is. So the area most off the coast of South America, that's where the waters are the warmest, but it is warming now in all sections here significantly. Now, the Climate Prediction Center has some of the values dropping off slightly, probably because of a Kelvin wave passing through, but as you can see, the water temperatures in region 3, 3.4 are quite warm, well above the minimal threshold criteria for El Nino. So, Climate Prediction Center declared an El Nino 2 weeks ago. Clearly, we are in one. We're at the beginning of one. This is going to be a big event, and it's going to last a long freaking time. So, just keep that in mind. We're going to be dealing with this El Nino for another year or year and a half. So, mark my words. Okay. Let's take a look what's going on in the sea surface temperatures. Well, we have four distinct areas to talk about. One is the large pool of incredibly warm ocean water temperatures in the central Pacific Ocean. That's been there all winter long. Area B is what some people believe to be the negative PDO, but if you look at the sea surface temperatures, I'm not sure it's a negative PDO anymore. I think it's more like neutral because we have some areas of warm water off the coast of British Columbia, some cold water in the Gulf of Alaska and off of California. So it's not uniformly cold, it's not uniformly warm. I think it's neutral. But again, not everybody agrees with me on that. Then we have area C, which is the developing El Nino. You can clearly see that. And notice the dark reds here, very, very coldest water, warmest water, I should say, off the coast of South America, region 1.2. And then here, this is the Atlantic, and you can see. Now, everyone's talking about how warm the Atlantic is, but you have to be careful here because the Western Atlantic Ocean is not warm. It is the tropical Atlantic and then the Eastern Atlantic in here, which is really, really warm, but not the Western Atlantic Ocean. We'll get into that in just a minute. And here is the ENSO regions. Again, this is region, here we're talking about this region right here. So, as you can see, the very, very warm temperatures, that dark brown and black here, 4 degrees, 5 degrees centigrade above normal. Yes, this is centigrade. So, 5 degrees, 4 degrees centigrade is 7 degrees Fahrenheit. So you can see they're very warm and then it's extending all the way out this way now. It's really rapidly warming. Okay, what's going to happen with the El Nino? Well, this is a prediction from the European, and you can see there's the region we're focusing on. Let me bring this fun here, and you can see that the model once again takes it. The red is the mean of all these different red spaghetti lines. So the red line and the black line, which is the produced forecast from May, almost identical. So it takes it to about 1.5 degrees centigrade by August here, and about 1.8 degrees by October, and then around 2 degrees by November, December centigrade above normal. This would be a high-end, moderate, low-end, strong El Nino type of event. Of course, here, remember, it is still going on as we head into winter. Now, this is the CFS forecast, and again, pretty consistent. The the number of lines, if you look at the dashed black line for the mean, and it gets it to about 1.7, 1.2 by July, 1.8 by September and October. Not, on the borderline of a strong El Nino, which is 2 degrees centigrade or warmer. So it's on the board. Now, many of the measures you can see do bring it above 2 degrees. Up here, they do have it crossing the 2-degree threshold, but not all of them do. And then here we can take a look at the Australian model. Now, the Australians have been the most bullish with this. They really have been. And let me show you what I mean here. The bottom left map or image, you can see that's the Australian prediction from from May 6th. And it had August at plus 2.2 centigrade, and then October but 2.5. But here in the upper right, you can see that it's even warmer, 2.4 degrees centigrade above normal by August and 2.7. Now, in fact, it actually gets it by 2.8 centigrade above normal in region 3.4 by October. If that happens, it would be the strongest El Nino on record. Let me see here if we can call this up. Nope, you can see that. So we can see that that's what it would be, the strongest El Nino on record since 1900. If it happens, now we don't know if this is correct, but the thing is, this El Nino is developing so fast and so rapidly that it might be the Australians are correct. So, in fact, let me do this for you. Let me just blow this one up and see if you can see how big. You can see it in more detail. Here you go. Look how warm it gets by November. 2.8 degrees. You see that? Really, really warm. Unbelievable. Okay. So now the other thing to talk about here is comparison of the El Nino. Now this comes from Jeff Baradelli down in Florida, a great meteorologist, a friend of mine. And you can see here what he did was he compared the 1982 El Nino in June. You see the same date, June 11th, 1982. There's the El Nino. See it right there. But look how chilly the ocean water temperatures are. The North Atlantic. Okay, some warm, some cold here. The Pacific, very negative PDO here. You can see the cold water in the Central Pacific. Now look what's going on here. This is the bottom one. Okay, this is June 11th, 2023. Exact same time date. All right? And you can see some 40 years later. And look how amazingly warm the Atlantic is. Compare this to this. Look at the El Nino. It's much stronger here than here. See, it's much, much stronger here. And then look at the Pacific Ocean. We have lots of cold water here. We have a little bit here, but it's much, much warmer in the Central Pacific Ocean than what we saw in 1983. So also look off the coast in the Indian Ocean. Much warmer down here. Look at the South Atlantic. Much warmer here. Look at Australia. Much warmer there. So the oceans all around the world are dramatically warmer than they were 40 years ago. And this was one of the second strongest El Nino on record, the 1982-83 El Nino. It would become that. We're already much warmer than that. So the other thing to point about this is the Atlantic. So let's talk about the Atlantic here. Now this is getting a lot of attention. You can see the incredibly warm water, the dark reds here, plus 2.5 degrees centigrade above normal in the tropical Atlantic from the Azores down to Cape Verdes, and then very warm all the way to the Gulf of Mexico. Most of the warmth is in the Eastern Atlantic. But the other thing to point out here is the North Atlantic, and right in here. Here is where the warmest anomalies can be found in the entire Atlantic basin. Now the dark red here is almost brown, so we're talking 3.5 degrees centigrade above normal. Off the coast of France and England and Ireland and the North Atlantic and off the coast of Spain. Interestingly, look at the Western Atlantic off the East Coast. It's cold here. Now why is the Western Atlantic so cold? Well, we'll get to that. That's a really good question. So, what's really important here is not so much the tropics right now, though obviously it is so important, but this warm water right here. This was really, really important in terms of getting the pattern back to normal. So let me show you what I mean. Now you may have seen this graph before. Again, this is coming out from, you can see, no operations, and you can see this is the North Atlantic basin. There, right here. And you can see as of 2023, there's the red line. So here you are. You can see what day of the year it is. Okay, 181 is going to be like July 1st or July 2nd. So we're almost there. You can see it's much warmer than any other year we've had. Dramatically warmer. It has just skyrocketed. Before, back in April and May, it was warm, but now look what's happened in June. It has really exploded upward. So, and again, all of this is because the ocean water temperatures are just warmer everywhere around the globe. They really are. And now there's a lot of reasons for this. No doubt that the oceans are warming because they're consuming the amount of carbon dioxide putting into the atmosphere, which is causing the Earth to warm. And the oceans are a heat sink. They take the carbon dioxide and they bury it into the oceans, but it causes the oceans to warm over time. There's no doubt about that. Okay, now let's take a look at the big picture here. This is the jet stream map from June 4th, and this was the mega block, very pronounced. You could see it. When this block is very big here, this has been around for most of May. And it's the reason why the Midwest had the driest April and May on record. The driest May on record in the Midwest and much of the Eastern Plains. This sort of a mega block, been there for 30 to 45 days, as of or at the end of May, beginning of June. Now, the reason why it's a mega block is because of the trough. So look at the lines that go like this. See? Like the Greek letter omega. So do it again. See that? Like the Greek letter omega. Okay. Now, notice the trough here. See this trough? This is a permanent trough on the East Coast and the West Atlantic Ocean. And these dark blue areas represent low pressure. These are negative anomalies, low pressure. So you have low pressure coming off the coast, going into the West Atlantic Ocean. The trough is bringing down cool, high pressure, okay, north winds, and then you have these storms moving off the coast, causing upwelling, disturbing the warm water and turning it over so that the cold water 100 meters down, 200 meters down, gets a chance to come up to the surface. And that's why the Atlantic, Western Atlantic, off the East Coast is cold, not warm. So just keep that in mind. This is really cold stuff, and this here's the warm. So what this means is that unless this changes, if you have hurricanes coming off Africa and beginning to develop, they're going to run into a rapid degradation, falling apart when they get into the Western Atlantic Ocean approaching the southeast U.S. coast. This has got to change. Otherwise, you're going to have a lot of strong hurricanes out here and a lot of weak ones here. So the mega block pattern is going to be a problem for the hurricane season. Now, on the good news is if you don't want that activity to hit the East Coast, then you want this trough to stay here. If this trough stays here, you're not getting any hurricane activity on the East Coast this year of any significance. None. Not going to happen. That's a very powerful trough. Okay. Now, let me show you how this connects to the global pattern. This is an image for the North Atlantic. All right. So here is, as you can see, let me get my arrow here. Here's the mega block, and there's Minnesota, the Midwest. Here's the East Coast. And here's Great Britain. You can see right there, this France and Spain and Germany. This is Europe, Scandinavia, Norway, right? So we have one omega block here and a second omega block in Great Britain and the Northeast Atlantic. This omega block is being fed by this massive warm water here, the warmest ocean water temperatures in the Atlantic Basin, either in the South Atlantic or North Atlantic, right here. This warm water, this is anchoring a blocking pattern, the omega block. So that warm water is causing a second omega block to form. Now this one has been around for about 2 weeks. And it's caused, a lot of warm water, a lot of warm temperatures in Europe the last several days. I'm sure you've heard, maybe you haven't heard about it, but if you follow the weather closely globally, you'll know that they had 30 degrees centigrade in much of Europe, and the heat's building rapidly. And all the rain is being forced to the south, and that's the other thing. Just like this omega block is forcing all the rain to the south. So you've had flooding rains in Oklahoma and Texas, portions of Kansas, the deep south. The jet stream is being forced to the south, right across here. And this trough is attacking the Bermuda High and weakening it. So you don't have a strong Bermuda High, which means you're not pulling dust from Africa, so the Atlantic Ocean gets very, very warm. And then the energy goes into southern Europe, Spain, heavy rains, above normal rainfall last 2 weeks, right? Okay. Italy, the Mediterranean, Corsica, Sardinia, Turkey, Bulgaria, Greece, all well above normal rainfall last 2 weeks. But northern Europe, Poland and Sweden and Norway and Germany and France and England and Ireland, they're not getting shit. They're really suffering from lack of drought, lack of rain here, and it's getting to be pretty bad. And again, the main culprit is this area right here. So this omega ridge, now here's the thing. This ridge means you get a trough here and a trough here. So there's your trough, and there it is in the Central Atlantic. But when you have a trough in the Western Atlantic Ocean, you have a ridge up here and it becomes the omega block. So this pool here, this omega block, is anchoring the pattern across the northern hemisphere because it is connected to the ocean water temperatures in the Northeast Atlantic. That's what that means. So when you have a block in here, you have a ridge in the Western Atlantic and a block in central Canada and the northern plains. So this is a problem for the East Coast, for the East Coast hurricanes. This blocking pattern is going to keep a trough in the Western Atlantic Ocean, and it's going to turn everything out to sea unless it changes. I'm not saying it could change. This could change next week. Fine. But if this holds, this would protect the East Coast from hurricane activity. If it holds. I don't know if it's going to hold. Okay? And again, this is just looking into, the rest of June and early July. We have all of August, all September, October to get through. And of course, the pattern is not going to last. But as long as this does, it'll protect the East Coast. Okay? All right. And of course, it also causes more blocking in Canada, South Central Canada, and the Upper Plains. So this is the one which has to change first. Let me show you what I mean. Okay. Remember we talked about the trough on the East Coast? Let me show you. This is the last 30 days from May 8th to June 6th. Look how cold in the East Coast. -2 to -4 degrees below normal. This is Europe. Look how warm it is underneath the block. Okay, 4 degrees centigrade above normal over the past 14 days. Now, look at Ukraine and Western Russia and Belarus. They've been quite cool relative to normal because they've been in the trough right here. This trough here is keeping it cool. But this block is keeping it warm. And let me show you more on the East Coast. Temperatures the last 7 days. Look at these temperatures. This is in June. Look at the anomalies. Are you kidding me? And then the bottom right is the last 14 days. Holy cow. All right, what happens next? Well, here we go. This is June 11th. This is just a couple days ago. This big upper low came down. There's the block right here, and it brought some rain into the Midwest, you can see, and the southeastern states. And then, but again, it's just a brief intrusion. This upper low, this trough on the West Coast cannot get into the Midwest. The energy keeps dropping south from Canada, and it's blocking this feature. Here you go. This is another example I'm talking about. We just talked about this image. So now let's take a look what the jet stream is going to look like on June 19th in the North Atlantic. Okay, look at the date, June 19th. Here we go. We have the block here in Scandinavia and England, and then another block in eastern Canada. It looks about the same. Look at the trough right on the East Coast. See that? Right along the East Coast. And another one in the Eastern Atlantic Ocean. Now there's some indication that the blocking is going to get pushed to Scandinavia, and that could cause the pattern to shift a little bit. So that's something to keep in mind. That would be good to see the blocking going to Scandinavia. That would allow some rain to get into Western Europe where they need it really badly, and also some rain getting into the Midwest in week 2, but we'll see if that actually happens. This is the rainfall for the past 7 days. You see the black line? Look how all the rain is forced to the south, running in a northwest to southeast orientation, right down from Wyoming down to Oklahoma and Arkansas, then across the deep south and along the East Coast, but not in the heart of the Midwest where the drought is really building, in Iowa, Minnesota, Illinois, Indiana, Michigan, Wisconsin, the Dakotas. The MJO, the next 2 weeks, not a problem. It turns into the neutral circle you can see here on the red, the blue, and the purple lines, and it stays in the neutral circle. It goes briefly into phase 4, then it collapses and goes to sleep in the neutral circle, so not an issue. All right, the next 7 days, let's talk about our possible nor'easter. First, okay, this is for Thursday afternoon. All right, so this here is a monster trough. Look at the size of this trough. This is June. This is June, people. There's the blocking pattern. So a trough here, a trough here. Omega. See the omega? Omega. See that? Now, there's a piece of energy here coming out of Colorado. Now, if this feature goes straight across, this is a nice rain event for the Midwest and into the Mid-Atlantic. But look what happens. It gets shoved southward because of this huge upper low and trough on the East Coast. It gets crushed completely. Nice short wave here. Gets wiped out here. This is now Friday. and gets pushed all the way down to Georgia. Amazing. Let me show you what I mean. This here is Friday afternoon, evening. This upper low, by the way, which comes down, it causes low pressure to form right here. And we get some rain in eastern Virginia, perhaps Pennsylvania, New Jersey, New England, New York State, some showers, that sort of thing. Again, with cool air coming in behind it, more amazingly cool temperatures. Now, here comes another piece of energy. This is Saturday, June 17th. Okay, so the trough here, this trough here begins to unify. See right here? It comes one big trough, and we go to June 18th, and now we have a unified trough. All right? Now we still have a split flow because of this huge upper low, but it's beginning to move away now, beginning to move towards the northeast. So this upper low now survives a little stronger. It goes to Missouri. See that? We have low pressure at the surface and in the mid-levels of the atmosphere. Now, it's going to be forced down to the south, but it's not going to be crushed as completely because the upper low is finally moving away. It's finally moving to the northeast. And as a result, look what happens. Okay, here's the European showing the same sort of thing. The upper low is weaker, and this short wave is stronger. It's not getting crushed, and as a result, it heads towards North Carolina and it becomes a coastal storm on June 19th to 20th. Meanwhile, look at the main jet stream. It does this and it splits. A piece goes over the block, a piece goes down towards Florida. Okay? But all of this has got to move across the Midwest. Once the block gets out of the way, this strong Pacific jet will move right across the Midwest and the plains and bring in the typical El Nino rains. But not until. You have to get the block out of the way. And this block is connected to the one in Europe. Here you go. Here's the GFS for June 18th. Father's Day, nice rain thunderstorms in Iowa, Missouri, Arkansas. But look what happens. It doesn't go due east. It drops southeast. See that? See how it drops southeast? This is 1920. You have low pressure in Georgia in June. Okay, high pressure to the north. This looks like a winter storm setup. Really, it does. Coastal nor'easter. Okay, rain developing in the Tennessee Valley, Virginia, up into Pennsylvania, New York. All right, so this is June 21. Look at this thing. Okay, goes to Georgia inland or either on the coast or inland. Now, the European takes it to Tennessee, Kentucky. Now, this would drive some rain into Indiana, Ohio, where they really need it. So this would be good for them. And then you have a lot of rain or light rain or numerous showers up and down the East Coast this time next week. Wednesday night, Thursday. Look at this thing. And it finally goes up into Ohio. And the rain goes all the way to maybe to Chicago, if you can believe that. That'd be super nice to see. Very slow moving system, high pressure to the north, blocking pattern, keeping the system very slow moving, not allowing it to go out to sea, and of course keeping the temperatures cool with all the cloud cover. Look at these temperatures for week 2. Are you kidding me? No, excuse me, this is the 6 to 10 day. Okay, this takes us to June 25. June 20th, look at these temperatures below normal Fahrenheit. Unbelievable, not bad. Unbelievable for June. June is going to end up being another chilly month. And then 30, next here, let's take a look at this. This now is the extended European here to 276 hours, June 25, 26, and June 28. Now the pattern shows the big block is appearing breaking down a little bit. We're getting ridging in the eastern Canada, but not a block. So you have a trough here on the east coast and a trough here in the eastern Pacific. This could allow for some rain and storms to get into the Midwest and the upper plains, and that continues to June 28th. As long as, now here the trough is in the Ohio Valley. Now, if you were to get hurricane activity in this kind of pattern, it would come up further closer to the coast because the trough is not here, it's in the Midwest. So there's a bit difference here. So that's something to see, and again, this potentially allow for a weather pattern to develop if this trough retrogression were to continue into the first week of July. Meanwhile, in Europe, what does it look like? Here's day 10, June 24. We still have a block, you can see, in eastern Canada and the one in the northeast Atlantic and Great Britain and a trough in between. And that means, again, not much changes. Once the block in Great Britain breaks down or moves to Scandinavia, then things will change in the US. But I do not know when that's going to happen. And then finally, last 2 points, there is a tropical concern to watch out for. Here is the 200 millibar velocity potentials from the European ensemble. So again, the black box here, see the black box? This is the Atlantic Ocean, see that? Okay, so that's Mexico, the Caribbean, all the way to Africa. So this is the black box here, right? And then this is the time frame, June 19th, 21, 22nd. The green represents positive energy or rising motion. And during the hurricane season, when you have green like this in the Atlantic basin, it often means possible tropical development. All right? So this would be in the Atlantic basin in particular. Notice where it is. This side over here, Atlantic, not the Caribbean. The Caribbean and the Gulf of Mexico are in the yellow, which is sinking air, which suppresses tropical activity. So Eastern Atlantic, if it happens. And indeed, this is my last image here, last slide. Here's the European ensemble around June 19th to 20th, and then 21. You can see there's a fairly high percentage. Look at the color. This is tropical depression, not tropical storm, tropical depression. And then you have 40%, 45% probability, maybe 50 or 60 in some of these areas. It looks like maybe yellow, so that might be 60. So maybe 60% around that time frame. Now again, with the trough on the East Coast, anything that approaches the East Coast is going to be pushed rapidly out to sea. But it's something to watch out for, so we'll see what happens. Anyway, hopefully you liked the presentation. I know this was a little long one, but like I said, a lot to talk about. This is meteorologist DT from Weather Risk. I will see you over on the Twitter page and over on the Facebook page and over on the website.